Hi, this is Hilal. In this video on Mathematical Economics series, we will try to solve a problem that was asked by a friend on the Telegram channel. The question is like this. In a two-good world, a consumer's utility function is given by the following. We are being given a utility function that is u of xy is equal to maximum of xy. That is the maximum value of the numbers in the parenthesis. Okay, where x and y are the amounts of goods consumed. The price of each of the two goods is $2. Okay, so each good costs $2 for the consumer. The consumer's income is $100. We have to draw the indifference curve and find out his utility maximizing consumption bundle or bundles. Okay, so let's write the utility function. We have a utility function u of x y is equal to maximum of uh, x y. Okay, this is our utility function. And what is the price of x? Price of good x is $2. Price of y is also 2, and the consumer's income is, let us say, m is equal to 100. Okay, so these are the things which are being given to us. Now first we need to draw the indifference curve. How do we draw the indifference curve? Let's take any arbitrary utility level. Let us say u is equal to let's say u is equal to 10. Okay, we will try to see when u is equal to 10 which combination of goods the consumer will consume. Okay, so when u is equal to 10, okay, how will we get a u is equal to 10? Okay, so let's try to draw here. Let us say we have x and y. Now utility will be equal to 10 when either the consumer consumes 10 units of x or 0 units of y. Okay, because this u is equal to maximum of xy, that means what is maximum of 10 and 0? It will come out to be 10. Okay, either the consumer will consume 10 units of x and 0 units of y, or he will consume 0 units of x or 10 units of y. Okay, uh, like this, because maximum of 0 and 10 is also 10, or he will consume 10 units of good x or 10 units of good y. And in this case also we have what is the maximum of 10 and 10. 10 and 10, we have the maximum value of the 10 and 10 will be 10. Okay, we take any arbitrary utility level and we will try to figure out how can we draw the indifference curve. Okay, now what will be the shape of the indifference curve? Let's draw the regular x and y axis. So we have x here, we have y here. Okay, now first point is when x is equal to 10, y is equal to 0. Okay, let us say here it is 10 and y is 0. Let us say it is 10, y is equal to 0 on this axis. Obviously when x is equal to 0, y is equal to 10, so let us say this is our another point 10 0, and x is equal to 10 and y is equal to 10. Another point will be this very point. Okay, now what will be the shape of the indifference curve? Indifference curve will be like this. If we join these pointers, this will become inverted L-shaped indifference curve. That is the opposite of when we have the minimum. When we have the Leontief indifference curve, the Leontief indifference curve will look like this, as I have shown you how to draw the Leontief indifference curve for the perfect complements, if I remind correctly. So the inverted L-shaped curve will be for the max of the utility. Okay, I hope I am making myself clear up to this now. So this was how to draw the indifference curves. Okay, now find out his best utility maximizing consumption model. Okay, when will the consumer maximize his utility function, utility consumption bundle? Obviously the consumer will consume that very good whose price is low compared to the other good. Okay, that will give him the maximum satisfaction. Okay, let's say we have two goods here, x and y. If the price of x was 3, price of y was 2, the consumer will obviously go for the cheaper good because he will try to maximize his utility. Okay, now the problem here is we have price of x is equal to 2, price of y is equal to 2. Okay, now where will the consumer choose his optimal bundle? We need to find here. Okay, now there could have been three cases. Since if let me make it more clear, if price of x was, let us say, less than price of y, okay, if that was the case, then the consumer could have consumed all of x and none of y. Okay, none of y. Okay, let me draw here the budget constraint. Let me draw here budget constraint in general terms. So we have uh, maximize maximum of x y. Okay, and our, let us say, u is equal to this, and subject to price of x into x plus price of y into y is equal to m. Okay, this is our general budget constraint. So when the price of x is less than price of one, obviously y, obviously the consumer will consume all of x because it is comparatively cheaper than the other good. Okay, in this case consumer will consume all of x. Okay, so he will consume, that is, he will consume in this case all of x. So what is the price of x? I will not write here. So he will consume uh, all of x, that is, let me write it properly here. So price of x times the amount of x plus, since price of y times the amount of y he will consume will 0 is equal to m. In this case the consumer will consume m upon price of x. This will be the optimal condition here, or optimal bundle. That is he will consume m upon px and 0 units of y. Okay, similarly, if price of x was greater than price of y, obviously the consumer will consume all of y and none of x because y commodity is obviously comparatively cheaper than the x commodity. So in this case we have same intuition, that is he will consume all of y and none of x. Okay, so what will be the optimal combination here? So I will write here. So this is price of x times he will consume 0 units of x plus price of y into y is equal to m, or y is equal to, since this term is 0, so he will consume m upon price of y. So he will consume, in this case he will consume 0 units of x and m upon py units of good y. Okay, and another case could have been if, which is the case here, price of x and price of y are same. In this case, let us say price of x is equal to price of y. Okay, when the both goods have the same what you call the same price, then what will happen? In this case, obviously the consumer is indifferent. Okay, in this case the consumer is indifferent, and what will happen in this case? The consumer will consume either, let me make it clear, either all of x, either all of x and none of y, or I will write 0 of y. So when he consumes all of x and 0 of y, so we would have the case of x would have been equal to, the combination would have been this combination, that is m upon px and 0, or he will consume all of y and none of x. Okay, so that means he will consume this very bundle which we have shown here, 0 and m upon py. Okay, so the consumer in this case will have it is what you call the optimal consumption bundle at the corner. Okay, so we would have the corner solution. Now coming to the question, what is the price of x? It is 2. Price of y is equal to 2. When we have this case, what will be the optimal combination here, or optimal choice? Let me rub this out. So now we have, since we have u is equal to u x y is equal to maximum of xy, and what is the budget constraint? We have price of x is 2, so we have 2 times x plus 2 times y is equal to, what is income? 100. Okay, since price of x is equal to price of y is equal to 2, okay, so we have this very combination. In this case, what will happen? The consumer will, I have shown you in general terms how to derive. So in this case, the consumer will consume either all of x and 0 of y. Okay, all of x, that means he will consume m, which is total income upon price of x. What is total income? Total income is 100. What is the price of x? Price of x is 2, and he will consume 0 units of y. So the optimal consumption bundle will be either 50 and 0, or the other optimal condition would be that he will consume or all of y and 0 units of x. Okay, so in this case, our optimal condition which I derived earlier will be that he will consume 0 units of x or m upon py. What is m? M is 100. What is the price of y? It is 2 also, so it is equal to 0, 50. Okay, so the point to say is he will consume, the optimal bundles will be, optimal bundles will be, he will consume 50, 0 or 0, 50. Okay, this will be the corner solution also. Okay, the consumer will either be at this point consuming 50 units of x and 0 units of y, or he will be here. Okay, 0 units of 0 units of x and 50 units of y, and the consumer will not be at any point on this indifference curve. Okay, let me remind you people again, I am just a student of economics, not any professor or teacher of the economics. In that capacity, if there are some mistakes in my videos, I will love to be rectified, and obviously you have to verify whether I have done the right calculation or the methods which I am using are right. So it's not every time that my calculations will be right or my methods will be right. I'm just making myself more useful for you people. In their capacity there could be some mistakes. Thank you.